Hello everyone, my name is Munib Siddiqui from Chonbuk National University, Department of Computer Science and Engineering. In this presentation, I will talk about importance of context in semantic segmentation of images. Here is the roadmap of my presentation. First, in abstract, I will briefly go through present my overall work. Then I will introduce the task of semantic segmentation and recent methods in the area of semantic segmentation and what problems these methods so far have. And I will propose my own method. Then I will show our experimental results and we finish this presentation by conclusion. So in this paper, we present the importance of contextual information in improving the performance of semantic segmentation algorithms on scene images. First, we choose a backbone instead of the ART network, which in our case, we choose HRNet-v2. Then we incorporate an context and encoding module of Deep10, which is another network, into HRNet-v2. We achieve improved accuracy of 1.1% mean intersection over union and 2.0% of pixel accuracy on ADA20K benchmark dataset. What is semantic segmentation? Semantic segmentation is the task of per pixel classification of objects in an image. It gives us a comprehensive scene description like object category, location, and shape. Most of state-of-the-art methods are based on fully convolutional networks, which is adopted from image classification task. However, this model lacks to integrate contextual information into the algorithm. As you can see, arguably this is the first semantic segmentation network that is adopted from image classification task. However, this network lacks to integrate contextual information, which is very important for the task of semantic segmentation. For instance, looking at the C1 can intuitively understand that the entity above the C is more likely to be a shape rather than to be a car. Deploying a layer to encode such a statistic feature as a context information can certainly improve the performance of the network. Thus, we propose context encoder to integrate contextual information into the network. The context encoder learns an inherent visual dictionary. The residuals are calculated by pairwise difference between the input visual descriptor, which is actually an output of the network, and a 32-word visual words. Then we have a smoothing factor, and then we aggregate the output of these residuals and assigning weight and upsample, and then get the predicted image. How this encoding layer works. It's an end-to-end learning layer, which means all the components of encoding layer is differentiable with respect to the input X and the parameters code words. Therefore, the encoding layer can be trained end-to-end using standard stochastic gradient descent with backpropagation. For our experiment, we use ADA20K dataset, which is a fully annotated image of 150 object classes. It provides us 20,000 of training data, 2,000 of validation, and 3,000 of test data. Here is an example of the original image, semantically segmented objects, instance segmentation, which is out of the scope of our work, and parts of objects, which is also useful in terms of context information. In here, we visually compare our results with the original HRNet-v2. As we can see, the HRNet-v2 fails to find the lamp, while ours can detect the lamp using contextual information, and also the curtain in here, while ours can find the curtain, and some other improvements as we can notice. And in the second row, we see that our work has less noise compared to the original HRNet-v2. More examples of our results for comparisons are provided in here. HRNet v2 lacks to properly classify. As we can see in here, our networks has better classification compared with the ground truth. And in here we can see that our network performs well compared to the original HRNet v2. And also we don't have noise in here, which HRNet v2 certainly has, and more car classification. Then we compare our results quantitatively with other state-of-the-art. As we can see, HRNet v2 outperforms all the previous works in terms of both mean intersection over union and pixel accuracy. By integrating encoders to use contextual information, our model outperforms HRNet v2 by around 1% mean intersection over union and around 2.4% pixel accuracy. To wrap up this presentation, in this work we study the importance of semantic context with respect to the task of semantic segmentation. We integrated the encoding module to state-of-the-art network of semantic segmentation HRNet v2. Then we quantitatively and visually illustrated that our proposed method can improve the performance of original HRNet v2, indicates the importance of contextual information in improving the performance of semantic segmentation algorithms. Thank you for your attention. Would you have any question regarding the content of this presentation? Please contact me via provided email address. Thanks.